In the previous class, we studied graph. Understood? We studied graph of real valued functions. We studied graph of x square and x cube. X square, x cube we studied in the previous class. So the first type was polynomial function. The second type is identity function. Then third type. Can you see the screen? Third type is modulus. So not modul. Yes. 1 minute. Third type is constant function. Constant function. Aryan, Shivani, Deva, Kirti, all of you clear? Audible, Shivani, Kelkalo, alle? Aryan? Okay. So the next is constant function. Constant function, I will explain the definition. The function is function is defined from real number to real number. The function is defined from real number to real number, and f of x equal to a constant or a fixed number. Constant means what? A fixed number. I can give you one example which is generally denoted by the letter C. Constant or fixed number generally denoted by C. I can give you one example. Okay, I can give you one example. For example, f from real number to real number, f of x equal to a constant. Say for example, say 3. It is an example for a constant function. Or f of x equal to 9 is an example for constant function. Constant function means the image of x is always 3. Whatever be the value of x, the image of x is always 3. This is an example. Or f of x equal to 9 is another constant function. F of x equal to 9 is another constant function. So the constant function means the image is a fixed number. Function is defined from real number to real number, but the image of x is always a fixed number given. Real number means 1, 2, 3, 4, 5. After explaining the graph, you can ask me doubt. The second one is also real number 1, 2, 3, 4, 5, etc. F of x equal to 3 means the image of x is always 3. This is an example for constant function. F of x must be a fixed number. That's all. So the image is always 3. Image is always 3. Meaning that 1 has image 3, 2 has image 3. Every element has image 3. It is a function because every element has a single image. 1 has a single image which is 3. 2 has a single image. 3 has a single image. So it is a function. So constant function means the image of a number is a fixed number. Image of a number is a fixed number. So it is a definition. This is an example for a constant function. All of you clear? Deva, Rakshana, Shivani, you please respond. The constant function is clear?
Yes, sir.
Yes, sir.
Okay. Deva, I hope you have understood. Deva.
Yes, I understood.
So the graph, this number will be given in the question. Okay. Normally will be given in the question. So for example, I am going to draw the graph of f of x equal to 3. I am going to draw the graph of f of x equal to 3. Let the constant function be. Suppose it is given to us. F from R to R, f of x equal to 3. How to draw the graph of the constant function? We have to draw the graph. Here, how to draw the graph? F of x is denoted by the letter y. Understood? F of x is denoted by the letter y. So y equal to 3. To draw the graph of a function, the first step is f of x is denoted by the letter y. So I want to draw off the graph y equal to 3. Let me draw a table first. Y equal to 3. I want to draw the graph of the constant function f of x equal to 3. I told you that whatever value you substitute for x, the value of y or f of x is 3. The value of f of x or the value of y is always 3. So if x equal to 0, the value of y is 3. So whatever value you substitute for x, the value of y is always 3. Like this, etc., etc. So I am going to draw the graph of the constant function f of x equal to 3. X-axis, and this is y-axis. And you have to mark the points. Okay, 1 minute. Let me mark the point 1, 2, 3, 4, etc. This is -1, -2, -3, etc. And here -1, -2, -3, etc. Here 1, 2, 3, etc. So let me plot all the points. All of you please listen. 0, 3 is the 0, 3. 0, 3 is this point. This is 0, 3. 1, 3 is the 1, 3 is here. 1, 3. 2, 3. It is here. 3, 3. -1, 3. -2, 3. -3, 3. If you include the fractions like 0.53, 0.73, etc., you will get more points. You will get more points if you include the fractions. So look like a line. Understood? So this is the graph of the constant function f of x equal to 3. This is the graph of the constant function f of x equal to 3. So the graph of f of x equal to 3 is a horizontal line having y coordinate 3. So in this way we can draw the graph of f of x equal to 2, f of x equal to 1, etc. So without any drawing this table, it is very simple. If you want to draw f of x, graph of f of x equal to 2, the same approach. If you want the graph of f of x equal to 1, you just draw a horizontal line passing through 1. Just draw a horizontal line passing through 1. It is the graph of the constant function f of x equal to 1. And if you want the graph of the constant function f of x equal to -2, you may draw the graph, draw a horizontal line passing through -2. It is the graph of f of x equal to -2. So from this example, it is clear that the graph of the constant function is a horizontal line. Understood? And it is passing through the value y coordinate equal to that fixed number. The y coordinate will be the given fixed number. Okay, you please draw the graph. And if you have any doubt, you please ask me. Okay? If you are okay, completed and no doubt, please raise your hand. You have to send me the graph after the class. Okay? So the constant function is clear. F of x equal to a given fixed number. Okay? Shivani, Rakshana completed. Deva, Aryan. Okay. Deva, are you clear? Deva?
Yes, sir.
So the constant function is over. The next is then okay, let me explain the domain of the constant function. Look at the arrow diagram, then you can understand that. What is the domain of the constant function f of x equal to 3? Look at the arrow diagram, then you can clearly tell me the domain and range. for this particular function. What is a domain? Domain is the possible values of x. Yesterday in the previous class I specifically told you that if the question is about domain of a real valued function, ask yourself that can I substitute any real value for x? You just ask yourself. Look at the arrow diagram. Look at the arrow diagram. I can substitute any real value for x. 1, 2, 3, 4, 5, etc. I can substitute any real value, positive, negative, everything. So domain means the values of x. I mean the arrow started from which number? The arrow starts from all real numbers. Arrow start from all real number. Or x can be any number. Just memorize that. Domain of constant function is real number. Range. I am talking about domain and range of this particular constant function. Range. Range is the set of values of y. What are the values of y? That is range. For this particular constant function, the values of y is always 3. Y does not take other number. Y take only this value only, 3. So range is the values of y, which is 3. Only 3. For this particular constant function, range is set to 3. So the values of x is domain. X is in the left hand side and y is in the right hand side. The values of x is real number, but the values of y is 3 only. Okay, just write down. This is for this example. Okay. If you are okay, please raise your hand. If you are okay. All of you finished, completed. Deva, Aryan, Rakshana, all of you have finished. Okay. So we can go to the next one. So the constant function is over. The next type is fourth type. Fourth type is modulus function. Fourth type is modulus function. Modulus. Have you, let me begin with some example. After that I will generalize this. Have you seen this type of symbol anywhere? Mod -3, mod. This symbol have you seen anywhere? Shivani, Rakshana, Aryan. Have you seen this symbol? No. This symbol means that the removing the negative sign. This one is read as mod -3. Read as mod -3. This symbol is just to remove the negative sign. Just to remove the negative sign. Mod -3 is 3. Mod -7, 7. So modulus is a tool which is used to remove the negative sign. But for positive number, the same number itself. For positive number, the same number itself. But if there is a negative number, just remove the negative sign. So modulus is a tool which is used to remove the negative sign. All of you clear? Understood? All of you clear? Tell me.
Can you explain once again?
I will explain once again. Listen. Modulus. There is a tool, there is a symbol, modulus. It is written like this. This is read as mod -3. I am starting with an example. To make you understand, I am starting with an example. This one is read as mod -3. Mod -3 means that just remove the negative sign. That's all. Just remove the negative sign. So if you remove the negative sign, what do you get? You will get 3. Here mod -7. It is used to remove the negative sign. The mod is a tool which is used to remove the negative sign. Mod -7 is 7. Negative sign removed. So if there is a negative number inside the symbol, you just remove it. But for positive number, we just copy the same number. For positive number, no negative sign. So we just copy that. But for negative number, we just remove the negative sign. That is the definition of modulus. Understood? Clear?
Yes, sir.
So let me define modulus. Okay, definition of modulus. Definition. If I don't give the example for modulus, you cannot understand. The definition of modulus function is f from real number to real number, f of x equal to mod x. I don't want to draw the arrow diagram, I will draw the graph only. The definition of modulus function is this: f from real number to real number, f of x equal to mod x. This is the definition of modulus function. We need only graph. We need graph. And after that I will explain domain and range. I will explain domain and range. So if you want the arrow diagram, okay, I can define, I can explain, but in exam they will ask only graph. F from real number to real number means real to real. Function is real to real. Real means all the numbers, not only 1, 2, 3, 4, etc. Negative number, fraction, everything will be there. You may zoom the video, okay? If it is not visible, you can zoom it. The second one is also real number, 0, 1, 2, 3, 4, etc. Real means not only a positive number, negative number will be there. Fraction will be there in between the integers. So f of x equal to mod x. So the image of x is what? What does it mean actually? The image of x is mod x. So what is image of 0? Image of 0 will be mod 0. Mod 0, 0. Just removing the negative sign. 0 does not have any negative sign, so the same number is written. The image of x is mod x. 1 has the image. Mod 1 is 1. Mod 2 is 2. Mod 3 is 3, like that. But mod minus 1? Mod minus 1 is 1. Negative sign to be removed. Mod minus 1 is 1. You may zoom the video, okay? Mod minus 2, 2. Mod minus 3, 3, like that. In this way, clearly it is a function because we studied definition of function. Every element of first set has a unique image. Minus 3 has only one image, which is plus 3. Minus 2 has only a single image. So if you look at this arrow diagram, every element of first set has a single image. It is a function, there is no doubt, but I want to draw the graph. I want to draw the graph. So for drawing the graph, we have to begin with the f of x is denoted by the symbol y. F of x is denoted by the symbol y. Let me explain the graph. After that, you can ask me doubt. Okay, let me complete the graph. F of x is denoted by y, y equal to mod x. I want to draw the graph of y equal to mod x. You must have a graph sheet. If you don't have the graph sheet, okay, you may draw it on your notebook. X, y. If you put x equal to 0, you may zoom it. If x equal to 0, y will be mod 0. Y will be mod 0, 0. x1, mod 1, 1. Mod 2, 2. Mod 3, 3, etc. Mod minus 1, 1. Mod minus 2, 2. You can zoom it. Mod minus 3, 3. Like that. So I am going to draw the graph of y equal to mod x. All of you please listen. I am going to draw the graph of y equal to mod x. X-axis and y-axis are drawn. Okay, let me mark the point. 1, 2, 3, 4, etc. Minus 1, minus 2, minus 3, etc. Here 1, 2, 3, 4, etc. Okay, let me plot the points. Please listen. ഓക്കെ, ശിവാനി ഇതൊക്കെ പഠിച്ചു കഴിഞ്ഞതാണല്ലോ, ഒന്ന് വെയിറ്റ് ചെയ്യട്ടെ, ഇതൊന്ന് വേഗം പറഞ്ഞു തീരട്ടെ, ഇത് പറയാതെ പറ്റില്ലല്ലോ, ഇത് നമ്മൾ പഠിക്കാനുള്ളതാണ്. 0, 0. Where is 0, 0? It is at origin, 0, 0. Where is 1, comma 1? 1, comma 1 here. Where is 2, 2? 2, 2 will be here. 3, 3 maybe will be here. It's a rough plot. Minus 1, 1. Minus 1, 1 will be here. Minus 2, 2 will be here. Minus 3, 3 will be here. And if you include the fractions, they are real number. If you include the fractions, you will get more points. Like this. Join them. You will get a V-shaped graph. It will be a straight line, okay? You may mark the point here 1, 1, 2, 2, 3, 3. Minus 1, 1, minus 2, 2, minus 3, 3. Like that. It is a V-shaped graph. So it is a graph of y equal to mod x. So it is a V-shaped graph having vertex at origin. Vertex at origin. Please draw the graph. If you are finished, please tell me. I mean, raise your hand. Deva, are you okay? Understood? Deva? Please raise your hand if you have drawn the graph. So all of you have finished. So what about domain and range? Let me ask you. Shivani, you please tell me, Shivani, what is the domain of the modulus function? What is the domain?
Real.
Ah, yes, very good. Real number. How? Because can I substitute any real value for x? Y equal to mod x. Y equal to mod x. Just ask yourself. Can I substitute any real value for x? Yes. Modulus is defined for all real value of x. X can be positive, x can be negative, x can be 0. For all real values of x, modulus function is defined. So x can be any real number, but range is different. Range is the values of y. You see, I mean, or you look at the arrow diagram, you will get a good clarity if you look at the arrow diagram. The values of y, the arrows ending on positive number only, including 0. Understood? The range means the set of values of y. Or the arrows ending on which number? The set of these number will be range. You see that the values of y is only positive number and 0. You see that no arrows are ending on negative number. No arrows are ending on negative number. Arrows ending only on the positive real number, including 0. So there is a notation I explained in the previous class. The value of y will be all positive real number, including fractions. All positive real numbers starting from 0 up to infinity. Why up to infinity? 0, 1, 2, 3, 4, 5, etc. up to infinity. Starting from 0. So the symbol will be like this, starting from 0 up to infinity. Denoted by this symbol. The symbol means that the value of y starting from 0 and go up to infinity. 0 is included, so we use this kind of bracket in the side of 0. This bracket meaning that the number 0 is included. I explained in the previous class, okay? So you please write down domain and range. If you don't understand, you please tell me. I will explain. If you have finished, please raise your hand. Deva, Shivani, Aryan, clear. Rakshana, understood? Rakshana? Okay. So modulus function is over now. Domain and range I explained. And next is fifth one. We are studying important real valued functions. All these functions are given in textbook. The fifth one is Fifth one is greatest integer function. This is the most difficult function to understand. Greatest integer function. Let me begin with an example, okay? The modulus, the tool modulus is clear. The tool modulus is used to remove the negative sign, right? Then I am going to introduce a new tool or new symbol, which is greatest integer function. Let me begin with an example. After that, I will give you the proper definition of this function. Greatest integer function. Begin with example. Greatest integer of 5.6. This is read as greatest integer of 5.6. The greatest integer function means greatest integer of a fraction. The greatest integer of a fraction is given by greatest integer of a fraction means suppose the question is this, we will write the integer which is just before this number. We write the integer just before 5.6. What is the number just before 5.6? Look at the number line. Look at the number line. I will show you the number line. 5.8. Let me make a small modification. So greatest integer of 5.8. To find the greatest integer value of fraction, you look at the integer just before that fraction. Where is 5.8? 5.8 is here. 5.8 is here. So the greatest integer of 5.8 is, it is an integer just before that fraction. The integer just before that fraction will be 5. Let me explain more example. After that you can ask me doubt. So the greatest integer of a fraction is the integer which is just before that fraction. Another example is greatest integer of 3.9. Where is 3.9? In the number line. Where is 3.9? It is here. It is a fraction. The greatest integer of a fraction, how will you find it? It is given by the integer just before that fraction. What is the integer just before 3.9? The integer just before 3.9 is 3. In this way we will find out. So without even drawing the number line you can find it. 2.6. Without drawing, can I find its value? Yes. The integer just before 2.6. The integer just before 2.6 is 2. Let me explain the example. After that only you can ask me doubt. Okay. Greatest integer of minus 4.8. You must be careful if the negative fraction is given. Where is minus 4.8 in the number line? Let me draw another number line. This is minus 4, this is minus 5, this is minus 6, etc. Where is minus 4.8? Minus 4.8 is a number lying between minus 4 and minus 5. It is here. Minus 4.8 is a number which is lying between minus 4 and minus 5. Look at the number line, a portion of the number line. What is the integer just lying in the left side of minus 4.8? What is the integer which lies immediate left side of the fraction? Immediate left side. That integer is minus 5. So you have to take the integer immediate left side. Okay, it is minus 5. So this is the way. So for the fraction, these are about the fraction. So for the fraction, how will you find the greatest integer value? Just look at think about the number line. Consider the integer immediate left side of the fraction will be the greatest integer value. If the integer is given, you just copy the same number. If the integer is given, you simply copy that. Positive or negative, if you are given an integer, the same value to be written. But remember, in the case of fractions, you have to write the integer which is immediate left side of that fraction. Okay, for integer we just simply copy that integer. So these examples are okay. Shivani, Aryan, Rakshana,
Yes, sir.
Yes, sir.
all of it clear. So more examples are required. That's why I explain these examples. Let me give the definition of this. Definition of greatest integer function. Definition is this: f from real number to real number, f of x equal to greatest integer x. I explained the meaning of the symbol. Integer, the same number to be written, but for fraction, the integer immediate left side to be written. This is the definition of greatest integer function. F from real number to real number, f of x equal to greatest integer x. The symbol is like this. Okay. So all of you please write down. If you have finished, please raise your hand.
So one doubt, sir.
Tell me.
How minus 4.8 is equal to minus 5, sir?
So we write the immediate left. I explain again and again. The immediate left. The integer which lies in the immediate left side of minus 4.8 is minus 5. Is it correct? Minus 4, minus 5. In this way we plot the number line, right? Minus 5, minus 6, minus 6, minus 7. In this way the number lines goes, right? Is it correct? This is the way the number line goes towards the negative side. So minus 4.8 is a fraction which is lying between minus 4 and minus 5. The position may be here, minus 4.8. So greatest integer value will be the immediate left, the integer which falls in the immediate left side of this, which is minus 5. Okay, understood?
Okay, sir.
So you please raise your hand if you have written. I will draw the graph in the next page. I will draw the graph in the next page. The graph sheet is required. If you without graph sheet you will not get a good graph. The graph sheet is necessary especially for greatest integer function. So let me draw the graph in the next page. The table is not required for greatest integer function. I will explain, but drawing the table is not good because there are plenty of fractions. The fractions are important for greatest integer function, so including the fraction on the table is not practical. So without drawing table I am going to draw the graph of the greatest integer function. Without drawing the table I am going to draw the graph. You need a one complete graph sheet for this. The drawing the graph is very difficult for greatest integer function. X-axis and y-axis. One complete graph sheet is required. It is very difficult to draw the graph of the greatest integer function. This is 0. Let me mark the important points here. 1, 2, 3 up to 4. Let it be 4 up to 4. And in the left side there will be minus 1, minus 2 like that. Understood? Minus 1, minus 2, minus 3, minus 4, etc. And the positive side 1, 2, 3, 4, 5, etc. And in the below origin the number will be minus 1, minus 2, minus 3, minus 4. Scale is required. Anyway, till this step you are okay.
Yes.
And remember, they will not ask in exam. They will not ask why the graph go like this, why this graph go like this. They will not explain. So simply memorize the graph. I will explain a small part of the graph. I will explain only a small part of the graph. But in exam, they will not ask why the graph go like this, why the graph go like this. They will not ask. So you have to memorize the graph. I will explain a small part of the graph because explaining every segment of the graph take lot of time. That explanation is not required. So I am going to draw the graph. I will explain the small part of the graph, not the entire thing. Darken it. Okay. in the side of one you have to use a dot. I will explain the reason, don't worry. Let me complete the graph first. Okay, let me complete the graph first. And before that, remember, in the graph sheet will be there, right? The graph sheet will be there, so there will be plenty of horizontal and vertical dot lines. Understood? So that's why I told you that this graph is supposed to be drawn on the graph sheet. There will be plenty of dot lines. You see that in the graph sheet there will be plenty of dot lines. Please wait, let me include that. If the dot line is not available, the graph will be very difficult. You will make mistake. This dot line will be already there in the graph sheet, right? Not only this horizontal, vertical, the horizontal line will also be there in the graph sheet. Let me include a few horizontal and vertical lines in this way. Okay, 1 minute. Let me just wait. The left side also, just wait. You may start drawing the graph. Okay, you may also start drawing the graph.
Sir, apart from the lines in the graph, you want to draw this dotted line, sir?
In exam, you need not draw the dot line. This is supposed to be drawn on the graph sheet. Okay, you must draw the graph on the graph sheet. If you have the graph sheet, you please take it. If you are drawing the graph on the white screen, white paper, for the time being, you may draw some dot line like this. Otherwise, I am sure you will make mistake. You will make mistake, I am sure. So you please draw this setup. Okay. If you have a graph sheet, don't draw this dot line. Okay. If you have the graph sheet. If you have drawn all these things, please tell me. Don't draw the yellow colored line for the time being. If you have drawn this setup, you please raise your hand. Do you have the graph sheet right now? Do you have the graph sheet?
Yes, sir.
Okay. Rakshana finished. Shivani completed. Okay, let me begin the graph. So, first step is draw a horizontal line segment connecting 0 and 1. Draw a horizontal, this one, connecting 0 and 1. In the right side, you have to use a small dot like this. I will explain the reason after drawing the graph. After drawing the graph, I will explain why we are putting a dot in the right corner, right side. So draw a horizontal line, unit length, and after that, one step forward, upward, one step upward. Draw a horizontal line, again dot line. Just like a step. Have you seen the step? You may draw a dot line here, just like a step. But the vertical portion must be a dot line. Okay. Like this, you can proceed. Like this, you can proceed. Just like a step, the vertical portion, you may don't darken it, just use the dot line. Okay. The darkened one is the part of the graph. This dot line, just to understand that it goes like a step. Understood? And in this way, you can proceed towards left side also. Just like a step, you can continue towards left side also. Right side, you have to use a dot, small dot. I am continuing, same thing, I am continuing. Look like a step, right? It is look like a step. Here also you may show some dot line. So just like a step, 1 unit length, 1 unit height. Understood? So you may start from the origin, goes like this. Understood? 1 centimeter length, 1 centimeter height, like this. Okay. And in the left side also you may proceed same way. So they will not ask why the graph goes like this here, why the graph go like this here, this side. They will never ask. I will explain a small part of the graph because it will take time. Discussing all the segments of this graph take lot of time. I don't want to discuss that. I will explain only this portion only. Okay. So you please draw. For the time, first of all, you please draw the graph. If you have drawn the graph, you please raise your hand. Okay. Shivani, after the class you have to send me the graph. Okay. Aryan, Shivani, Rakshana, understood. All of you have drawn the graph. Okay. Then, so see, remember, they will never ask why this graph goes like this. For your understanding, I will discuss only a small part, not the entire thing. I don't want to discuss. The table is not required for this. Why the graph goes like this horizontally initially? Why the graph goes like this, starting from 0 to 1? I will tell you the reason. That the reason is simple. If x equal to 0, when x coordinate is 0, when let me start from origin. If x coordinate is 0, the y coordinate will be greatest integer 0. Y is greatest integer x, right? So if x equal to 0, y will be greatest integer 0. It is 0. Greatest integer of integer value, the same number. So when x equal to 0, clearly y equal to 0. So 0 comma 0, origin is a part of the graph. Yes, correct. Origin is a part of the graph. I will not discuss the entire thing. Only this segment I will discuss. The remaining part will be the repetition. Okay. And let me substitute next number after 0. Let me include a fraction also. Let me include fraction also, because the fraction is important in the case of greatest integer function. So in this case, this explanation will not be asked in exam, but for your understanding I am explaining this. If x equal to 0.1, x coordinate is 0.1, 0.1 is just maybe here, right? When x equal to 0.1, y will be greatest integer of 0.1. What is the integer lying in the immediate left side of 0.1? The integer which lies the immediate left side of 0.1 is 0. Without drawing the number line, you can understand that 0.1 is just in the lying in the right side of 0. So greatest integer of 0.1, the integer immediate left side of 0.1 is 0. So when x equal to 0.1, y value will be 0. When x equal to 0.2, y value will be greatest integer 0.2, 0. When x equal to 0.3, y value will be greatest integer of 0.3, again 0. When x value is 0.999, still 0.99 is fraction. So the integer immediate left side of 0.99 is also 0. 0.10, it will be here, right? 0.20, 0.30. If you plot all these points, you can see that you will get a point on the x-axis. 0.9990, very nearer to 1, right? 0.9990. But if x value jumps to 1, if x value becomes 1, y value will be greatest integer 1. When x value is 1, y value will be greatest integer 1, it is 1. So from 0.990, it is here. 0.990 is here. From this point, there is a sharp jumping to 1, 1. 0.990 is here on x-axis. But 1, where is 1, 1? 1 is here. Here is 1. So you can see a sharp jumping from 0.990 to 1. So there is a discontinuity. There is a sharp jumping. So for the discontinuity, there is a small discontinuity here nearer to 1, so we normally represent it by a dot. This dot means that there is a break, that's all. Okay, there is a sharp jumping occur at 1, so for that purpose it is denoted by a dot. That's all. So the remaining thing I don't want to discuss. In this way you can proceed. In this way you can proceed. You will get the remaining segments of the graph. Actually this will not be asked in exam. Okay, so I don't want to spend time for this type of explanation. Only the graph is required and the domain and range. These three are important. Okay, so the graph is clear to you. Graph is clear. Shivani, Rakshana, Aryan, Deva, graph is clear.
Yes, sir.
Drawing the graph is clear. Why the graph goes like this, that is not important, but I have given you a small idea. Okay, tell me domain and range. The domain and range is the important one. You need not write these things. Okay, these things you need not write, just to understand it. Okay, oh this can, oh I cannot delete. Oh. Okay, listen, these things you need not write. The domain and range is important. Rakshana, you please tell me what is domain. Rakshana, can you tell me what is domain?
So, we could see 1, 2, 3, 4.
Domain means you just ask yourself. Remember, in most of the questions, I think more than 90% of the question, domain is R. Remember, for most of the functions, I think 90% of the questions, the domain is real number. So you just ask yourself that, can I substitute any real value for x? Yes. Whatever real value for x, the function is valid. You can find out the greatest integer value for all real number. X can be positive number, x can be negative number, x can be fraction, x can be integer. For all real value of x, I can find out the greatest integer value. So x can be any real number. I can substitute any real value for x, including fraction. Clear, Shivani? Rakshana, Aryan, you please respond. Deva, clear?
Yes, sir.
The next is range. Now I am going to discuss range. Range is the values of y. What are the values of y? See, the values of y. You are taking greatest integer value of something. You are taking greatest integer value of something. What value you will get? What value you will get? If you take the greatest integer value of something, you will always get an integer value. Understood? You will be always getting integer value. Look at this. Whatever may be the number inside the box. Whatever may be the number inside the box. Once you take the greatest integer value, what kind of number you are getting? Right, look at the right hand side. What kind of number you are getting? You are getting an integer values. Positive integer, negative integer, etc. So you will be getting only integer value. If you take the greatest integer value of some number, you will be always getting an integer. That is the value of y. These are the values of y. So y is what? Integer. Positive integer and a negative integer. So y is set of integers denoted by z. Z means set of integers. Please write down. If you don't understand, please ask. If you are okay, 100% clear, then you can raise your hand. All of you have finished. So this one graph is important one. Remember, these graphs are required next year in 12th standard. Whatever topic you study in 11th standard, it is required in 12th standard. In the 12th standard, there is a chapter relations and functions. Second chapter is, in 12th standard, the first chapter is relations and function. In that chapter, you will learn the continuation of this chapter. You will learn types of relations, types of functions extra. Okay, the graph is required, and the graph is very important in 12th standard also. There is another chapter, area. There is a topic, area, so the graph is necessary for that chapter. So the greatest integer is over. So fifth one is greatest integer function, and then only one thing is remaining. One type of graph is remaining. It is not so important, but it is given in textbook, so I have to discuss that. The first time you are hearing this word. Sixth one, last type. Okay, I am talking about the last type, signum function. Signum function, let me write the definition. All of you please listen. This is the okay, by next class the chapter is almost over. I mean, a few questions are remaining. There is some good question, miscellaneous exercise. So by next class this chapter will be over. Okay, signum function, let me write the definition. Signum function definition is f from real number to real number. F from real number to real number, f of x equal to, can you see the screen? You can see the f of x equal to, in two ways we can write down, but only one method you have to understand. F of x equal to 1 if x is positive number. F of x equal to 1 if x is positive. 0 if x equal to 0. I will explain. You have to write the definition first. And minus 1 if x is negative number. This is the definition of signum function. You please understand the definition. F from real number to real number, f of x equal to 1 if x is positive, and f of x is 0 if x is 0. F of x equal to minus 1 if x is negative number. What does it mean? If you draw the arrow diagram, normally arrow diagram will not be asked in exam, but to make you understand what actually means, let me draw the arrow diagram. The function is defined from real number to real number. It is real, so it must contain the all real number, 0, 1, 2, 3, etc. Negative number, minus 2, minus 3, including fractions. The right side also real number, real to real, so 0, 1, 2, 3, etc. and minus 1, minus 2, minus 3, etc. It is a function. If you draw the arrows, you can see that it is a function. This says that if x value is positive, x means the values of the left side number is generally denoted by x. The left side number, these numbers, the left side numbers are denoted by, generally denoted by x. F of x equal to 1. So if x is positive number, the image will be 1. For all positive real number, the image is 1. What that is the meaning? For all positive number, the image is 1. For all positive number, image is 1. 1 is a positive number, image is 1. 2 is a positive number, image is 1. 3 is a positive number, image is 1. 4 is a positive number, image is 1. 3.5 is a positive number, image 1. Like that. When x equal to 0, image will be 0. For 0, the image is 0. And for negative number, for all negative numbers, the image is minus 1. For all negative numbers, the image is minus 1. For all negative number, image is minus 1. Arrows goes like this. Minus 4, minus 1, like that. So all the arrows will be ending on three numbers, minus 1, 0 and 1. So without drawing arrow diagram, can I find the domain and range? Yes. Without, if you have any confusion, draw the arrow diagram, you can understand. Domain is the set of values of x. Which value I substitute for x? I can substitute positive number, 0 and negative number for x. The arrows originating from all real numbers. arrows starting from all numbers. So the domain is R. Let me complete it. After that you can ask me doubt. Okay. Range is the arrows ending on which number, that is range. Values of y is range. Y will be the elements at which the arrows end. Y will be the elements at which the arrows end. Arrows ending on -1, 0 and 1. Other number will not be range. The range consists of -1, 0 and 1. The range is -1, 0 and 1. I will draw the graph in the next page. So all of you are okay. The signum function definition is clear. Aryan, Rakshana, Shivani, definition is clear to you?
Yes, sir.
Yes, sir.
Okay, so you please draw the arrow diagram and write domain and range. If you have finished, please raise your hand. Deva, do you have any doubt, Deva?
No, sir. Understood.
I will explain the graph in the next page, okay? So you finish. So this is the last topic. Okay, almost. Yes, I will discuss the graph. 1 minute. The graph of the which kind of function? Signum function, right? What is the definition? Let me write the definition once again. F from R to R, f of x also denoted by y, right? F of x is also denoted by y. Also denoted by y. Y equal to 1 if x coordinate is positive, 0 if x equal to 0, -1 if x is negative, negative number. Definition. Table is not required because it's very simple graph. Without any table we can draw the graph. X-axis, this is y-axis. Let me plot some important points. 0, 1, 2. Without any table it's very easy to draw the graph. -1, -2, -3, -4, 1, 2, 3, etc. And here -1, -2, -3, etc. So when x equal to 1, remember whatever may for when x equal to 1, y equal to 1. Is it correct? Look at the arrow diagram. So I can discuss easily. When x coordinate equal to 1, corresponding value of y will be 1. So 1, 1 is there. When x equal to 1, y equal to 1. Let me plot it. Table is not required. When x equal to 1, y equal to 1. When x equal to 2, corresponding value of y is 1. When x equal to 2, y 1. When x 3, y also 1. 4, when x 4, y 1. If you include the fractions, you will be getting more points, but it will be look like a horizontal line. So this side you will get a horizontal line. Shall I extend till y-axis? No, you should not extend till y-axis, because when x equal to 0, y equal to 0. Here there is a point. So this does not meet y-axis. When x equal to 0, y equal to 0. Look at this. When x is 0, y is 0. When x is 0, y is 0. So if you are starting from right hand side, initially you have to go like this. Horizontally you have to draw. But this graph never meet y-axis. Approaching towards y-axis, when x equal to 0, the graph immediately jumping to origin. Graph going like this, approaching towards y-axis, but does not meet y-axis, immediately it will be jumping to origin. Meaning that there is a discontinuity. Does not actually reach y-axis. Let me complete the graph. After that you can ask me doubt. -1, -1. Correct? -1, -1. Where is that minus, sorry, where is that minus 1 minus 1? Minus 1 is here. When x equal to minus 2, y equal to also minus 1. Same way. When x equal to minus 3, minus 1. You'll be getting more points like this. Here also going like this but does not meet y-axis. There is a discontinuity here. We use a dot, draw a dot, meaning that this does not meet y-axis. Okay. So this is the graph of the Signum function. Okay. Please draw the graph. If you have any doubt, please ask me. Memorize the graph. Okay. Memorize the graph. Deva, do you have any doubt? Deva, you can ask me doubt.
No, sir.
Aryan, if you have drawn the graph, you may leave the meeting. Now it is 9:30. The chapter is, yes, finished. I will discuss some extra problem from this chapter in the next class. Deva, okay. If you have drawn the graph, you may leave the meeting. Okay.
Thank you, sir.
Okay.
So can you show the greatest function, that graph, sir?
Ah, yes, I will show you. Okay.
Thank you, sir. Bye, sir.
Okay, bye.